So, I'm sure you all remember what function notation is, or I hope you do. F of x is the same thing as y, pretty much. Okay. Instead of, like this equation I have with y equals 2x plus 3, you can change the y with f of x. And there's reasons for doing that. It's not just some useless thing that somebody came up with. And another thing you need to understand, function notation doesn't just mean f of x. It doesn't have to be f of x. The letter here, f, that's the name of the function. The variable inside, that's what the variable is going to be in the expression over here. You can use any letter you want to name the function. Usually it's f. But one of the nice things about function notation is if you're dealing with a lot of functions, let me write a few more. Write these down. So we have y equals 2x plus 3, we have y equals 1/2 x minus 4, and y equals 3x plus 8. If you got a lot of functions you're dealing with in the same problem, if you want a way to distinguish between the different functions, if they're all y equals, it's kind of hard to really distinguish. But with function notation, you can just choose a different letter for each function. So the top one could be f of x, this middle one could be g of x, and the bottom one could be anything, h of x. So in that regard, function notation makes it easier to keep track of different functions because you can name each function with a different letter. And then the variable inside the parenthesis needs to be the exact same as the variable in the expression after the equal sign. And it doesn't have to be x. Variables don't always have to be x, it could be anything. So probably one of the first things you guys learned is how to evaluate a function. Real easy to do. So let's do this as our first example. Write that function down there. G of x equals negative 2x squared plus 3x. I'll show you here in a second what I want you to evaluate. Evaluate g of negative 3. You remember what that even means? What does it mean? Yeah. Exactly. Plug in, yep, exactly. Plug in a negative 3 for all the x's. Pretty easy. That's called evaluating a function. Now, I'm not opposed for you to try doing it in your head. I'm sure a lot of you could. But it's real good practice just when you're making a substitution into a function. It's good practice to make the substitution with a parenthesis. So instead of negative 2x squared, it's going to be negative 2 times negative 3 squared plus 3 times negative 3. You just follow your simple order of operations. Negative 3 squared is 9. 9 times negative 2 is negative 18. 3 times negative 3 is another negative 9. We get negative 27. As easy as this is, I still want to give you just one more example here to practice. So here's a new function, h of n. H of n is the square root of n plus 2. I want you to find h of 16. Make sure you simplify the result. All right, real quick, just turn to the person behind you or next to you somewhere, see what they got. See what you got, see what they got. Talk about it.
Take 18, take out 9, put 2 to 9, simplify to 3.
So, what happens with this 16?
Goes in for n.
Goes in for n right here.
So it becomes 18.
So it becomes the square root of 16 plus 2. It's the square root of 18.
To go to the 9 with negative 2.
And it's 3 root 2. So, I don't know, you don't have to really expect much evaluating on the assignment. It's pretty easy. Let's move on to combining functions. So, combining functions, we're going to deal with polynomial, rational, and radical functions. Here's the deal. You guys really pay attention. We'll do polynomial functions first. We'll take a little break. I've got a pretty funny how it should have ended this show. Then we'll do rational functions. Then I've got another pretty funny how it should have ended. And then we'll do radical functions. And then we should be out of time. You may not ever be tested on vocab in here or even on the SAGE test. But it's kind of important to know what words mean, to have a coherent conversation about mathematics. So you've seen the word polynomial before. You might have forgotten what it means, but I know you've seen it. I gave you a definition back in Unit 1. It's an expression with, doesn't poly mean many? So a polynomial is just something with a lot of terms. Okay? Rational. The root word is ratio. Ratio means fraction. Rational functions are things in the form of fraction, like 3 over x plus 2. That's a rational expression. Anyway, so we're going to combine those. Radical, we've been dealing a lot with these. Radical means root. So radical functions are functions that have roots in. So we're going to learn how to add, subtract, and multiply these, which you already know how to do, actually. There's nothing new here. There's absolutely nothing new in this. But let's start with polynomials. There's 2 polynomials. Write them down. This is the nice thing about function notation. We've got 2 different functions, so we can distinguish between the 2 by naming them different names, g and h. So you've seen a problem. Well, maybe not. Actually, this was back in secondary 2. You've seen stuff like this. Been a while. So your task is to find g plus h of x. This is how it's written in most textbooks: g of h or g plus h of x. I've written this here in blue because some textbooks write it this way. Some textbooks write it this way. It means the exact same thing. G plus h of x or g of x plus h of x. All it means to do is add the two functions together. So I'd recommend you first write it like this. So write it like this. Write the two functions in parentheses, but a big fat plus sign between them. This ought to look dang familiar now. This was a question on first unit. Not in function notation, but I gave you a question like this on your test on unit 1 where two functions were in parentheses and you're supposed to add them. And for the most part, you guys did all right. There were a few of you that tried to use the distributive property on here. Are we supposed to distribute here? No, we're not multiplying, we're adding. You only add like terms, exactly. So this is a pretty easy problem. Write down what you think the answer is real quick. Remember, you're only adding like terms. Like terms have to have the same variable and exponent. All right, consult quick, see what you got. Come on now.
Did the same thing? 4x squared, what again? 4x squared minus 4x plus 12.
All right, I'll agree with that. Let's switch it up. Try this one now. Part B. Try that one. Come on. The sooner we can get through this, the sooner we're done. H minus g of x. That's one notation. You may also see it like this. H of x minus g of x. Means the same thing. I'm not quite sure what you'll see on this H test. It might be written one way or the other. Scroll. Oh. Well, then it shows the answer. Hold on. Anywho, it's not like this one's any more difficult, but you have to be more careful with your minusing and subtracting negatives and that sort of thing. But it's still, I would say, an easy problem, right? So we have negative 2x plus 9. This time we're subtracting 4x squared minus 2x plus 3. I'm not too picky about where you put the terms or in what order, but technically the term with the highest exponent ought to come first. So the 4x squared, are we combining with anything? We do have to distribute the negative sign though, so I guess technically we are combining it with the minus 1. So that becomes negative 4x squared. What happens to the 2x? They actually cancel out because a negative times a negative makes a positive 2x combined with a negative 2x. So they're gone. And then 9 minus 3 is 6. Negative 4x squared plus 6. I mean, you could write it as 6 minus 4x squared, but it's supposed to be in descending order. Actually, before we do the next example, I want to sneak in a part C here. Let me write this. I just thought of something that you're going to see on your homework. Find, what did I name the functions? G and H? Find G plus H of 3. Now, let's talk about this first before you start trying something so you don't end up having to erase. What do you think that means?
Put 3 in for G and H.
Yeah, both of you are right. There's actually two ways you could do this. You guys listening? You could plug a 3 into the H function, and then you could plug a 3 into the G function and add those two numbers together. Okay? Or you could add the two functions together and then plug a 3 into that combination. It's going to give you the same answer. You guys understand what I'm saying? Let me show you both ways. Let's first plug a 3 into both functions separately and then add those two numbers together. So if you go back up to the functions here, if you plug in a 3 to the G function, let's not take too much time with it. What is it? G of 3? All the x's change to 3's. You got to square it first and then times it. 9 times 4 is 36, minus 6, plus 3. Come on, this is easy stuff. 36 minus 6 plus 3 is 33. If you plug in a 3 to the H function, H of 3 is negative 6 plus 9, so that's 3. So if you added these two together, it's going to be 36. That's one way of solving this. You could plug a 3 into H, plug a 3 into G, add those two numbers together, and what do we get, 36? You guys all right with that way? The other way you could do this, though, is to add the two functions together, which we already did here, and then just plug in a 3 to that. So we plugged in a 3 here. What are we going to get? 3 squared? Oh, come on. 3 squared. 9 times 4 is 36. 36 minus 12 plus 12 is 36. So we got 36 either way. You guys see that? So those are your two ways of doing a problem like this. You could either plug the number in separately and then add the numbers, or you could combine the functions first and then plug the number into the combination. Either way, same number. So the answer here was 36. Okay, let's move on. Two new functions. Hang with me here. Let's just finish the example. I got a little break coming up here for you. So just finish this one. Obvious answer, but what am I asking you to do here? Multiply the two functions. So this is a little more involved than just adding like terms, because you can multiply any type of term together. So it'd be best here to put them in parentheses. 3n squared plus 2n minus 1 multiplied by n minus 2. This is also something that you did way back in Unit 1. Just got to remember to distribute every term in the first parenthesis to every term in the second parenthesis. I'm going to give you guys a go at it, see what you can make of it. So, 3n cubed from here, and then there you get minus 6n squared. Here you get 2n squared. There you get minus 4n. Here you get minus n, and there you get plus 2. So combine your like terms. 3n cubed minus 4n squared minus 5n plus 2. And that's it for polynomials. Really wasn't anything new, was it? Stuff you've done before, just with functions now. Rationals. Remember, rationals means functions in the form of fractions. So this also you have done before. Back in Unit 3. Unit 3 wasn't your guys' best performance. You were more rookie status on that one. But it's still something you ought to be able to muddle your way through. It's not quite as easy as adding polynomials. You don't really need parentheses because there aren't multiple terms. It's just one term added to another term. 3 over x plus 2 over x plus 2. Ooh, let's see what you remember. You can or cannot add these. What do you think? You can add them once you make the denominators the same. That's right. Well, they're not the same. Wait, you're telling me that this won't work? Didn't we talk about this a lot? You can't add something to a denominator to change the denominator. You can multiply something to it. You can't add to it. So this denominator has an x plus 2. This one does not have an x plus 2. So what does it need?
X plus 2.
It needs an x plus 2 over x plus 2. But now this denominator has an x plus 2 and it has an x. This one only has an x plus 2. So it needs an x over x. Both denominators have to have the exact same thing. So I would keep the denominators in parentheses, but numerator you need to multiply it through. So this one on the left becomes 3x plus 6 over x plus 2 times x. 2x over x plus 2 times x. All right, now that we have the same denominator, what do? Add the tops. Add the numerators. If they have like terms, 3x and 2x makes 5x plus 6 all over x plus 2 times x. It's a little harder than polynomials, but it can still be done, and it's not new. You guys have learned this. You've tested on it, and most of you passed that unit. So it shouldn't be a big deal to quickly remember this. 3 times 2. All right, you guys try this one on your own. F minus g with those two functions there. Here's first step. You have to multiply each side by the other side's denominator. So on the left side here, I multiply by x plus 2 over x plus 2, because this side had an x plus 2, so this side needs it. But now this left side has an x plus 2 and an x minus 1, so I needed an x minus 1 over here. top and bottom. Okay. Next step, I keep the denominator in parentheses, but distributed in the numerator, you get 4x squared plus 8x out of this numerator. This numerator turned into 2x minus 2. I did see quite a few of you right here have the wrong constant. It's plus 2, not minus 2. Why is it plus 2? Yeah, exactly. You're subtracting this entire numerator. You're subtracting a negative 2. Subtract negative 2 is plus 2. So you get 4x squared plus 6x plus 2 all over x plus 2x minus 1. Now, you guys know Math Excel can be a bit, I don't know, picky. I don't know if they're going to want you to keep the denominator in parentheses or if they're going to want you to multiply that out. I don't know. If it doesn't like this answer, they may want you to multiply that together. Yeah, I'd accept this. Sometimes this one doesn't, but sometimes it does. Okay, one more.
F times G, same two functions. Come on now. Part B, same example. On this one?
No.
Same two functions, F and G, but now I want you to multiply them. Come on. Some of you aren't putting much effort into this. You're not interested in doing well on the test, and you're on the right track. Continue putting no effort into it. That's great. Fail the test. Good on you. Same two functions as before, now multiply. Is this one going to be easier or more difficult? I would say easier to multiply fraction. Why is it easier to multiply fraction? Do you have to have the same denominator? Just multiply straight across. You multiply fractions straight across. This one should be pretty easy compared to the last one. Still, it's nothing new. It's just we're using function notation. But you've all done problems like these before.
Four x times 2 is 8x. And then you have x minus 1 times x plus 2. Math Excel might be okay with this form of it in parentheses. It may want you to multiply it out. I'm not sure. I would take this on a test. But wouldn't be that hard to multiply it out anyway. And then, ooh, we might have forgot something. What about this? Can you do that? This x is part of this term x squared plus x minus 2. You can't separate and cancel out little pieces of a term. You can cancel out a whole parenthesis term with another parenthesis, but you can't cancel out a part. This is no good. This is not even close to being correct. You can't cancel out those x's. That's really all you can expect from rationals. Not too bad, I hope. Did I tell you one time I forgot to press pause when I was recording and I showed it how it should have ended? Yeah, and YouTube emailed me saying that my video had copyright infringement or something. It was really scary. I was making a recording like this of a lesson, but I forgot to pause it, and I showed everybody how it should have ended, and then I posted it to my website, and YouTube emailed me that I infringed copyright laws or something. It was pretty serious. I don't know. They've been watching my math videos. They want to learn, I guess. They know everything. They know everything about everybody. Yep. Alright, here we go. Last problem. Two new functions. Write them down quick. Oh, great. Now I spoke ill of YouTube, and I'm going to post it to YouTube. This is going to come back and haunt me. Okay, try this one. F times G. F times G. Yeah, make sure you simplify your result. Multiply the two. It's pretty recent stuff. We actually kind of reviewed this last time, how to multiply radicals. So if nothing else, at least start by writing the problem down. 3 times the root squared of 2x cubed multiplied by 4 times the square root of 6x. I know you are all capable of writing that down. Yep, that's right. Now, when you're multiplying like this, you multiply terms on the outside together. 3 times 4 makes 12, and then you multiply terms on the inside together. So we're going to get 12 times the square root. Keep going. Of 12x to the 4th. And then you try to simplify. 12, for example, is 4 times 3. Well, what does that mean? You take a 2 out, and it multiplies to 12. 3 stays on the inside. What about x to the 4th? Comes out as x squared with no x's on the inside. So we have 24 x squared times square root of 3. Because it divides evenly. Yep. Sorry, I did tell you a lie. There is one more. This is not the last one. This is definitely the last one. Promise. I'm not interrupting you back there, Colton, am I? Am I interrupting you at all, or am I? I don't want to be rude or anything. Okay. Now, hold on. I see some of you working. What are we working on? Because I don't see many like terms here.
Make the radical the same,
Got to make the radicals underneath the same.
which will be 5.